A bakery has two options for cakes. Cake A requires 150 grams of flour, while cake B requires 75 grams of flour. The bakery has 50 kilograms of flour available. In order to profit, the bakery needs to produce at least 500 cakes combined. So as long as we have 500 between the two cakes, we're good, we're making money, okay? The bakery knows that cake A is most popular and therefore makes at least 100 of them. I didn't identify this one when I assigned the homework. So if you missed it, it's because I didn't tell you about it. So cake A is most popular and you need at least 100 of them. So in this scenario, you actually have three inequalities, three restrictions to the scenario, okay? Let's define our variables. So even if I don't ask you to do this, you should do this, okay? So for A, X, Y, okay? X is cake A, and Y is cake B. And you would want to say number of, okay? We're talking number of cakes. What's the implicit constraint? Does anybody remember what that is? It's the one that you should always have when it's a word problem. We're saying that both X and Y are greater than or equal to 0. That's B, implicit constraint. Usually worth half a mark. C, let's write the inequalities. And you know what? Because I'm going to work with them right away, I'm going to have them side by side for all three here. So C is going to be along here so we can do the work that follows afterwards. Inequality number 1, there's up to 50 kilograms available of flour, okay? We need to have a restriction for that. And I don't know if you noticed, but there are coefficients. There are numbers that talk about the amount of flour, correct? Did you see the 150 up here and the 75, right? So we need 150 grams for cake A and 75 grams for cake B. There's a problem though. This is grams, this is kilograms. I'm going to tell you right now, you don't have to worry about that on the cumulative, you don't have to worry about that on the exam. I just thought I'd throw it in here to remind you how to convert, okay? 50 kilograms, let's do that up here. 50 kilograms, let's turn that to grams. Anybody know how many grams in a kilogram? I don't know if you have that on your study sheet, but 1 kilogram has 1,000 grams. So you go 50 times 1,000. So instead of saying we have 50 kilograms of flour available, we can just say 50,000 grams. It's the same thing, but now we have everything in grams. So we're going to write it like this. 150 for every cake A and 70 grams for every cake Y. That combination, right, has to be less than or equal to 50,000 grams. So why did I do the 150? Why did I do the 75? Because those two numbers tell us how many grams of flour we need for each cake. So that's, and since we're putting a restriction on the amount of flour, that's why I put the 150 and the 75 there. Okay? Inequality number 2. We need at least 500 cakes. That's combined. So we're only talking about the number of cakes, okay, folks? So we're going to go X, which represents the number of cake A, and Y, which is the number of cake B. That combination has to be at least 500. So which way will our inequality symbol face? You should have the key words in your study sheet. Greater than or equal to, right? So this has to be greater than or equal to 500. And I'm going to cut this off here just to make sure we don't mix them up, right? And then last but not least is inequality 3. At least 100 cake A. I know it doesn't sound grammatically correct, but we need 100 of just the A, specifically A. So we're only talking about the X variable here. And which way is it going to go? If it says at least, then this X, the number of cake A, has to be greater than or equal to 100. And there you have your 3 inequalities. We could graph them now. And we will do that. Graph all possible solutions, that's D. That's when we actually graph it, okay? So let's go ahead and do that. I'm going to give you a little bit of time to do that yourself. So basically, I want you to figure out the X and the Y intercept for both of them, okay? And then I want you to rewrite, meaning Y mx plus b, right? For all 3 of them. So can you do that real quick? Find the intercepts for all of them, and then we'll graph it together, okay? Okay, keep going. So note that I found the intercepts for the first one. I'm rewriting it already, so I go straight from here, bring the 150 over, subtracting.
Denise Torres, please come to guidance. Denise Torres, please come to guidance.
You can leave this as is, or you can divide this. That gives you negative 2x. And if you could just, I mean, it's not the biggest deal, but if you want to have the exact same answers, 50 divided by 75 is not a whole number. So I leave it like this. I leave it like that. That's how I enter it into my calculator. Okay. Let me focus. And remember, this is a reminder because it's been a long weekend, right? This is going to be a solid line. The true region, if it's less than, the true region is found below the line. But we're going to shade above. And I hope you remember why we're doing this, because we're using reverse shading. We're shading the false region so that it's much easier to find our solution region. I'll do the same with the other ones. By the way, this is going to be 500, 0, because if y is equal to 0, it's just x 500, and vice versa. So it's the quickest intercept calculation you'll find. Okay. Rewriting, also very easy. Just make sure you don't flip the inequality symbols. Quick reminder, what's the only time that you need to flip the inequality symbol? The only time that you have to worry about that? If you divide by a negative. I'll also tell you this, with a word problem, it doesn't really happen. Okay? It doesn't really happen with word problems. It does happen when it's just a plain old inequality without a context around it. Anyways, solid, that's another pattern that you're going to see with word problems. The true region, because it's greater than, the true region is above, we're going to shade below. I'm going to cut this here, kind of clean up my work. Okay. What about this one? What kind of a line is this? Vertical. You should have something on your study sheet. This is a special case. Vertical line. We don't need to clean up. It's already cleaned up, right? So we end up with just x. This is going through 100, 0. It's going to be a solid line. True region. Where is it at when it's an x variable? If it's greater than, it is to the right. It's left or right if it's x. Okay. We're going to shade left. Circle that. Okay. Where are you going to shade? That's important. Do you remember how to graph a vertical line? 999, 999, 999, x minus 100, and so forth. So let's graph this. Okay, this is going to get a bit trickier with the graphing part because the numbers are bigger. Make sure you have a ruler so that it looks decent. We're going to make this fit. I'm going to make this fit the corner here. So I'm going to I will provide you with this on the exam. If you need to graph this, I'm going to provide you with a little x and y axis. Let's label first. This is cake A, and it's number of. You have to have a label and the units. Over here we have cake B, number of. Okay, now you have to be careful with the scaling. You have to make it fit, right? So look at all your x-intercepts, guys. Look at the x-intercepts. 300, 500, and 100. So what's the biggest number you need to account for? It's 500. So I'm going to make it like this. Watch here. I'm just going to space it equally. So 100, 200, 300, 400, 500, 600. That's pretty good. That's going to work for me. So I'm going to label every other one. And that tells me that I'm going up by 100. It's a bit small, so sorry for those of you that are back there. I would like to have the intercepts on there. That's why I'm trying to keep this. Now you look at your y-intercept. This is why I make you do the x and y-intercept, guys, by the way. so that you know how to make this fit your graph. What's the biggest y value you need to account for? 666, 500. So let's go up to 700 or 800 to make sure this fits. So I'm going to just try this. 100, 200, 300, 400, 500, 600. This is 700 up here. I'm going to make this work. As long as you're consistent, you're fine. Okay? The gaps seem a little bigger on the y-axis than they are on the x-axis. That is okay, as long as they're consistent within that. Okay, now plot. Let's do one at a time. This one here, 333. This is 300. This will be 350. So 333 is right about there. And then 0, 666. This would be 650. 666 is right about there. And I'm going to connect those. And I'm going to label it. Sometimes I just go like this. I just make an arrow going to this line, and I label it out here. 150x plus 75y is less than or equal to 50,000. That's one line. The other one is 500, 0, 0, 500. 500 zeros right there. 0, 500 is right there. Label that one too. X plus y is greater than or equal to 500. Just wait for now. Guys back there, just wait for now. Okay, till we're done. Yeah.
I think the line isn't it supposed to be like the x value for
Oh.
500?
Yes, this is wrong. 500 is right here. That's a good point. I missed it. So now what? Now what do I do? This is it, Mr. Dirksen. You figure it out. I'm going to hand this in because I don't want to erase. Don't do that, okay? It's fixable. So yes, it makes a bit of a mess. I just wanted to show you one last time that I'm human, okay? That's all. Oh, you don't need to show us, Mr. Dirksen. It's very clear. We don't need another example. Is that what you were saying, Ranveer? Because this is 500. So 500 zeros here.
Yeah.
0, 500 is there. So that goes there. You're saying I'm still wrong?
No, you're good.
I'm good now?
Yeah.
Okay. All right. Now it's the 100 line. The x equals 100. So that's right here. So all you have to do is, this one does get an arrowhead because it technically keeps on going. Please make sure if it's a word problem, don't go outside your quadrant 1. Okay? Please don't do the continuing. Don't do that because this is a word problem. It's just x is plus 0 and y is bigger than 0, right? So sorry, y is bigger than 0, x is bigger than 0. You're almost there. Right now it's just a system of linear equations, but it's inequality, so we need to add shading. Let's do one at a time. I'm going to stick to this one first. This one is my first line that I drew. I'm supposed to shade above. See, right here? That's why I'm asking you to do that here. So you put your ruler there and then you shade above, just lightly. So it literally means anything above that line is false. We don't care about that. Okay? So you're eliminating all of that chunk. It's not going to be used for our system. All right, go to the next one. This one calls for shading below. So I put the ruler on that line. Are you good? Am I going too fast? The next one is this line right here, and I'm supposed to shade below. I'm telling myself right here. So I'm going to just line it up, and anything below it, and make sure you stay within the quadrant, right, is gone. So now you're eliminating that further. So just to make sure you understand, every time I draw an inequality, I'm eliminating a region. I'm saying, no, not this one. Got to sell more than 500 all combined. So this won't work. Anything in here will not work. Okay? And last but not least, I'm asked to shade left of the vertical line. So you go put your ruler on there. And now literally you shade everything to the left of that vertical line. So everything is gone here. We already eliminated some of that section, but this just to make sure you understand what's happening. So anything here is gone. Okay? Which leaves you with one little sliver. You see that little sliver? That's your solution region. That's why businesses go, sometimes they go belly up, because the margin for them to make money is small, right? They need to like abide by all these rules and like all these regulations. So this is your solution region. If you could please write that in, that's important. Okay? Write solution in there. I go SOL with a little N. That's short for solution. Okay? All right. So now the corner points, the POIs. Okay? I don't know, I don't care where you do them. I will do this on the side here. Let's find them. All of these require the calculator. So let's go and type this in. Maybe you beat me to it. You figure it out. I'll do it on the side here. I'll type everything in. This is something that I would expect you to do on the cumulative as well. I'll give you a system. You have to type it in and find me the POIs. Okay. So I go x plus I don't know if you remember the trick for vertical lines. It's x minus 100 if you want to graph it at plus 100. Did I add that to your study sheet? I'm not sure. I think I'm running kind of out of time, so I'm going to let you add this to your study sheet, how to enter that. I feel like I did. Yes, I did. I have it right here on my study sheet. Let's graph this now. I don't see a thing. Remember, this is a good window. What should be my Y max on my window? It should be like 700, right? So we're going to go to our window, and my Y max, I'm going to set that to 700. And my X max should go to 600 or something in that neighborhood. You can use Zoom Fit. Maybe that'll work for you. Usually Zoom Fit isn't the greatest when it's a word problem. So I'm setting both of my X maxes, X max and Y max, to 700. Go to your window and do that, right? And then hit graph. That is something. My graph kind of looks like that. So we're good to go. I'm going to go find the one between the black and the blue line. So second, trace, intersect. I'm on the blue right now, hit enter. 100, 466, 67. That's my first one. Okay, second trace 5. I want to go between the blue and the red, so I'm going to go blue, and then it jumps to red, and then hit equals. That is, you can't see that really, but it's 166, 67, 333, 33. And the last one is this one right here, between the black and the red. So I'm going to go second trace 5. I want to jump to the red, so go up and down arrows. You're somewhere on the red. It immediately jump to the black line. Just hit enter and enter one more time. And it's 100, 400. You would get 2.5 out of 3 right now. 2.5 out of 3. What's wrong with these corner points? What kind of data are we dealing with? Number of cakes. So discrete data, right? So round POIs. And I don't care how you round. So it'd be 100, 467. It'd be 167, 333. So I round these ones to the nearest whole number. And 100, 400. Because you can't make 0.67 of a cake. I mean, it'd be a great cake, right? Cake that's 6'7". Anyways. And so that's the last part there. All right. Let me see here. I'm going to stop this. Oops.